Hi, I'm Mrs. B, and we're going to talk science. We're going to focus today on weather and climate. Have you ever seen the weather on an app, on a website, or maybe during the news on TV? You see a person and they say, today we're going to have a sunny day and 70-degree weather, and maybe they have some pictures behind them with some suns or clouds or wind, and they have numbers showing what the temperature would be, and we find out what the weather is to find out what we're going to wear for the day. So let's talk about weather and climate and what the difference is between the two. So weather is when we look out our windows that day. What's the current conditions? And a climate is more like the temperature almost all year around. It doesn't quite change like the weather would change from day to day. So let's look at some examples and see if we can sort them out. So if we have a snow day, do we think that's the weather or climate? So if we're looking at some snow one day, that's more like the weather for that day. If we are on a tropical island and it's breezy and warm, and we would go visit this tropical island any time of the year, usually we get around the same kind of weather, then we're talking about a climate. It doesn't change a whole lot throughout the year. What about if we're in a dry, hot place, doesn't get a lot of rain, doesn't get any snow, like a desert? Then we're talking more about a climate. Or what if we get some rain? If we get some rain, then we're talking about weather. So climate's also like the North Pole. There's always snow on the North Pole. They don't get sunny, hot days. So that would be more of a climate. So who are these people that can make predictions? These people that sometimes we see on TV telling us what the weather is. So to predict is to say what's going to happen in the future. And there are scientists called meteorologists. It's such a big word, I had to spell it with 2 cards. Meteorologists, and they study the weather. And they can help us make predictions about future weather. How do they make predictions about future weather? Well, they collect data. They collect information. And with this data or information, they look for patterns, something that repeats over and over so that they can make their predictions. So I did some research because I wanted to be scientific and like a meteorologist. And so I looked up how much rain we got in Albuquerque last May. And I drew a bar graph. Maybe you've made a bar graph before in your math class. I want to talk about the different parts that go on my bar graph so that you can create your own bar graph at home. And then I want to tell you about some of the information on my bar graph to see if maybe I could make a prediction about rain for this May, next month. So, if we look at my graph here, I have a title at the top. And my title is Rain in May 2019. So rain last year. I have a horizontal line. That's the line that goes across the bottom. Horizontal. And I have a line that goes up and down. That's vertical. Goes up and down. I have labels for each of these lines. On my horizontal line, I have a label and it reads days in May. And what I did here is that I put a little mark for every single day in May. How many days are in May? 31. So I have 31 little marks, little tick marks, and each tick mark has a number representing the 31 days. So 31 tick marks, starting from the number 1 all the way up to 31. Then on my vertical line here, I have a title that says rain. And the way that I found rain was measured in inches, so I wanted to include how the rain was being measured. This was the unit of measure being used, inches. So it's hard to see my numbers here, but it's actually less than 1 because we live in an area where we don't get a lot of rain. So I labeled it 0.1, 0.2, 0.3, 0.4, 0.5. 0.5 is less than 1. It's half of 1 in decimal form. So I have a title, I have labels for each of my lines, and then what I found was that last year in May, on the 10th of May, we got about 0.25, a quarter of an inch of rain that day. And then I found that on May 11th, the next day, we got less than 0.1, less than 1/10 of an inch of rain. And then we didn't get any rain until again on May 20th, we got a little bit more than 1/10 of an inch of rain. So there were 3 days in May of last year that we got some rain. So as a meteorologist, somebody who looks at data and studies the weather, do I have enough information with only 1 month of data, of information, to predict, to see what the weather will be in May of this year, next month? I don't know. I don't think I do. I think meteorologists look at years and years of data to make very good predictions. But I'm going to take a chance and make a prediction. I'm going to predict that based on my information here and the data I collected, that next month we're going to get less than half an inch of rain on any day, and that maybe we'll get 2 to 3 days of rain in May. That's my prediction, what I think will happen next month in May. Now, I think it's a lot of fun to make bar graphs, and maybe you want to make a bar graph where you are. And it doesn't have to be about the weather. For example, you could change it to exercise. If you're doing exercise where you are, like sit-ups, jumping jacks, maybe you're going for bike rides, maybe you're going for walks, you could change the title of your bar graph to say jumping jacks in May, or in April, because we're in April, 2020, and you could keep the same label on the horizontal line here, days in May. You would still have tick marks all the way from 1 to 31, and the corner would be 0, so really it's 0 to 31. And then you can keep track every day how many jumping jacks you're doing. Maybe there's a goal that you have or that your family has, and you can start to label on the vertical axis number of jumping jacks. And then maybe your goal is to do 50 jumping jacks in one day, but you got to build up to it. So maybe you count by tens and create tick marks, 10, 20, 30, 40, 50. And then as you're collecting data, collecting that information, how many jumping jacks did you do each day? Then you would draw a rectangle like I did, hopefully you can see that, for each of the days, and you can start to see in a month how many jumping jacks did you do. Will your graph look really low first, a little bit of jumping jacks, and then you did more and more and more and more and reached your goal? Or maybe at the beginning of the month you were going strong, dedicated to your jumping jacks, and then by the end of the month maybe you didn't want to do so many jumping jacks anymore. Maybe you moved on to jump rope. So create a bar graph about something going on where you are. I did it about the weather. And so how can you be a meteorologist where you are? I challenge you to maybe be the weather person where you are. So maybe you can check on the internet, ask an adult, go watch the news on TV, watch the weather forecast, go on apps, websites, and do some research so that you can share the weather. Maybe you're the one that stands in front of where your family, friends, wherever you are, and you start to say, today you can wear shorts because it's a sunny day. Or today let's stay inside, it's going to be a very windy day. Or maybe you do some research or you imagine going to a place in a different part of the world. Maybe you really would like to explore a beach. And so you do some research about the weather there. And then you share and make a little skit, presentation, kind of a newscast about what's going on with the weather there. Use your imagination. Be creative. So today let's recap. We talked about weather. And remember, weather is really what's the weather conditions, what's going on right now outside. Is it raining? Is it snowing? Is it sunny? Is it windy? Climate is when we see the same kind of weather over and over a year, like going to visit a tropical location, or maybe going to visit a desert, going to visit the North Pole. We also talked about meteorologists, scientists, who predict, right? They can tell us what the future weather is going to be. And the way they do that is by looking at information, at data, and they find patterns. Create bar graphs of whatever it is you're doing. Maybe you're trying to keep track of how many naps you're taking. You could set up a graph to see how many naps you're taking. Again, exercise, maybe number of snacks, whatever's going on where you are. So thanks for joining me today to talk about weather and climate. See you next time.
2, 1. Hello, mathematicians, and welcome to At Home with APS. I am Mrs. Sears.
And I'm Mrs. Gaudette.
And today we're going to work with you on some math. Are you guys ready? I thought so. Great. All right. So before we had come on a couple of days ago, you might have seen a routine that we did called the game of Buzz, or the game of Buzz that I remember. And it is an oral counting game, and from which what you're going to be doing is we're going to be picking a number, 1 through 9, and I'm going to remind Ms. Gaudette how we play this game, because we're going to play that with you today. So what we need to do is we need to pick a numeral from 2 through 9, and that is the number that we're going to replace with the word buzz in it. Okay, so for instance, if I took the number 2, I would go 1, buzz, 3, buzz, 5, buzz. Do you get it?
Yes.
Okay.
She's doing this because I have never played this game, and so I will have to see how many times I go, oops, and we have to start over again.
Now, we're going to try and get to, let's say, 30. Would 30 be a fair number to try and get to today?
Okay.
Okay, so I'm going to let you pick the numeral that you want to work with. So remember, it can be 2 through 9. And right now, we're just going to replace that numeral, whichever one you pick. That multiple, when we say that multiple of that number, that's when you have to say buzz.
Okay, I need clarification because you said it was buzz.
Oh, well, we're going to practice the first part as buzz, and then we're going to make it a little bit more complicated because I know you guys can do this.
Okay, so then I am going to do 3.
All right, so are you ready?
Yes.
Okay, and we have to go to 30.
Okay, I'm going to try.
All right, so I'm going to start off. I'm going to say 1.
2.
Buzz.
4.
5.
Buzz.
7.
8.
Buzz.
10.
11.
Buzz.
14. No, 13. Ah! See, it's harder than it sounds, isn't it? Okay, let's try it again. Let's see if we can do it. We've got to get to 30. All right, 1,
2,
buzz,
4,
5,
buzz,
7,
8,
buzz,
10,
11,
buzz,
13,
14,
buzz,
16,
17,
buzz,
19,
20,
buzz,
22,
23,
buzz,
25,
26,
buzz,
28,
29.
Buzz!
Was that fun?
I bet it was fun watching us do that one.
Takes a lot of thinking. Okay, so this next part, we're going to add a little bit of a twist to it. We're going to have 2 numbers that we're working with this time. So, for instance, if we were going to pick 3 and 6, it would look something like this. So we would say 1, 2, and then we would say biz.
So biz is for the first number.
The biz is for the first number, so that would
Okay.
be the 3, and then 4, 5. But what happens with our 3, because our next number is going to be our 6, we have to say biz buzz, because it's also a multiple of 3, and it's our new number that we introduced, which was our buzz number.
Okay. Woo.
I don't know.
All right.
I don't know. Do you think we can do this? I think we can do this. Do you want me to just stay with those 2 numbers and see where we get? 3 and 6?
Sure.
We can pick 2 different numbers. You can pick any 2 numbers anywhere from 2 through 9. So this is really, a variation of that game. But we'll try it with 3 and 6. Do you think we can do it? I think we can do it. Shall we go to 30 again?
All right, we'll try.
All right, ready? 1,
2,
biz,
4,
5,
biz buzz, because it's a multiple of 3.
You
Okay,
got
biz
it.
buzz.
7,
8,
biz, buzz. No, just biz. Oh, okay. So I messed that one up. All right. Now you're right, because I was thinking that 9 had the 6 and the 3 in it, but no, it would have been just the 3. It was the multiple of the 3. Let's try this again. 1,
2,
biz,
4,
5,
biz buzz,
7,
8,
biz,
10,
11.
biz buzz,
Oh, gosh, that was a hard one. 13,
14,
biz,
16,
17.
biz buzz,
Ooh, 19.
20.
Biz. I have to think about that one. Biz.
22,
23.
biz buzz. How
Ooh.
do I always get the biz buzz?
I don't know, because I think I started at 25.
26,
Biz.
28,
29.
biz buzz.
Woo! Yay.
Yeah.
See, and that was just with 3 and 6. Imagine you could try this with all different kinds of numbers, 2 through 9, and it could be very challenging. Reason you don't want to choose 1 is because then you would be doing this just about every time. You would be saying that number, that biz or that buzz within that same number. So
Well, everything.
it's going to be counted by 1. So best to pick a multiple that's a little bit higher. So that's why we said 2 through 9. But that was a fun little game.
It was.
I think that was definitely very interesting. Pat us on the back for that one. That was really very good. Good job. All right, so the next thing that we would like to go ahead and try with you is we have an open middle problem here. This is the first time I've done an open middle problem with you. So I'm going to try something and just see how this works. So if you notice, these are kind of very interesting problems because they give you different boundaries or parameters of which for you to kind of think strategically about what kind of numbers and where you would place these numbers to make something work. Perhaps it's an equation, perhaps it's an addition sentence or a subtraction sentence that you're trying to make sense of. But you're going to do something with each of these numbers strategically to try and figure out what an answer could be. So if you look over here to this problem, let me go ahead and read it for you. This is, it's off of a website called openmiddle.com. And what we did is we looked at trying to create an equation by using the digits. This is key. We can only use the digits 1 through 7 one time each. Okay? So that puts it a little bit harder on us to be thinking about which numbers we're going to put and place where, because we cannot use a number twice. All right? So we can only use the digits 1 through 7. This limited my thinking about it a little bit more because 8 and 9 were very important to the way I was trying to figure out some of the problems. We can only use them one time each, and we're going to fill in the boxes to make it true. Do you have a marker? Do you want? May I borrow that? Thank you. And we are very, very much trying to maintain our social distance for today. So as we are working through, we're going to kind of talk about our thinking for this problem. All right, so one of the things I want you to kind of take a note of also on this problem is it may be set up different than what you're normally used to seeing. If you notice over here, I have the sum on the left-hand side. You may have always been able to see the two add-ins that you're adding together and then the sum on this side of an equation after the equal sign. This time, the sum comes before the two add-ins and the equal sign. Kind of interesting. So you got to think about, you can't just go 1, 2, 3, 4, 5, 6 and put those numbers in. Not going to work. Well, first of all, because we can't use 0, and in order to have like a tens place over here somewhere, I probably have to have some zeros in there to be able to add those single-digit numbers. All right, so as I was kind of thinking about this, I first thought about just doing that, just placing 1, 2, 3, 4, 5, 6 randomly in those numbers because I have 6 spaces there. But then as I kind of looked at the problem, I thought, no, I've got to be a little more strategic in the way that I'm placing my numbers. So I first started to think about, because again, I can't use 8 or 9. I couldn't have anything that has a higher sum of the two numbers to come together. I had to think very low numbers to start with to see that I could get that number over to be my sum here on the left-hand side. So one of the ones that I started thinking about is I just started playing with like a 12, because I could do a 1 and a 2 over here, okay? So if I did a 1 and a 2 over here, I had to very much be thinking a little bit more strategically as to what two numbers would I have to put over here, because given that if I did a 3 and a 4, if that 3 added with the 3 being in the 30, if I added that to my 10 over here, I would have had a 40. I couldn't have had a 4 here. That would have already messed my numbers up automatically. So I had to think a little bit strategically and to not be placing them just exactly in order. So the two numbers that I thought of next, I thought, okay, because I do want to have that 40 over here, and I know I have to use the digits 1 through 7, I thought about the number 30 and a 5. So if we did that, let's see if this works. Hopefully I have my numbers that are going to work and work for me, because remember, I can only use them one time. So if I had 35 plus 12, I had 30. So we had our 30 plus 10. And do this a little bit like our partial sums. That would give me 40. I had my 5. I'm going to add my 1s now. My 5 plus 2 would give me 7. Altogether, 40 plus 7 would give me 47. Let's see if that would fit in our problem. I think it would. What do you think?
It looks like it.
Okay, so I have used the digits 1 through 7. I have used them one time each, and I have made the equation true. Okay, 35 plus 12 equals 47. All right, perfect. What about you? What did you think about when you were thinking about this equation?
So I
Did you have
took
a
probably like 10 times to try to get this one. So what I ended up doing
And I'm going to move over here so we...
was I took my ones digit, and I was thinking, well, if I did a 6 and a 7, yes, I went this way. And I was just thinking, well, 6 plus 7 is 13. And this was after, if you notice, I said 10 times, multiple attempts where I kept going. I did a lot of 6 plus 2. Well, that works. It's 8. I did this a lot. So yeah, we'll keep going. Now in my 10 spot, I can put a 4 and a 2 here, right? A 4, 5, 6, 7. Nope, I already used my 7. Okay, hold on. Could I put a 2 and since I carried this, I don't have to count that as my 1. 1, 2, 3, 4. Does that work?
I think it does. So what you're saying, I'm just going to write it over here so we have it. So she has 43, okay, and that was the sum of those two numbers, which were 16 and 27. Those were the two add-ins that she used. All right. Did she use all of her numbers, 1 through 7, one time each? Yes, she did. And that was a good plan. I was going to also say there is another way to kind of think about this. You might be able to swap some numbers. I was thinking about that with mine. So I could still have that sum of 47, but instead of this time, maybe I did 32 and 15.
That's true.
So I kind of interchangeably did the way that the ones were in the equation to make my sum work on that as well. So just a thought. I'm wondering what ways you kind of have thought about this. Have you thought about any other different ways than that?
Yeah, a lot of wrong ways.
It is a bit challenging, but you have to be very strategic in the way that you do it. I challenge you to see if you can come up with a few different ones and let us know what you came up with. It'd be very interesting to see. You could possibly tweet them out to us at our At Home with APS. There's our little tweet that you could send it to us, or you could actually email us at the aps.distancelearning@gmail.com with some other solutions that you found on this particular product. Was this a good problem for you? Yeah, really made you think. It made me think about it too. It was quite hard. And as you say, you've got to make a lot of mistakes sometimes, but the mistakes are where you have those learning opportunities. So it's very fun to sometimes make mistakes and see it changes your thinking in the way that you're going to approach a particular problem. And that's what mathematicians do. They really like to make those arguments and construct those different solutions and things and ways to make the problem, and they're always trying to make sense of the math that they're doing. So, thanks. Ms. Gaudette's going to leave us here, and I have another routine that I wanted to be working with you guys on. Let me go ahead and grab this. So, this particular routine that we could be doing at home, you may need a number chart. You might also choose to do this on an open number line if that's what you want to, if that's what you might have available to you. You could also kind of create a hundreds chart of your own. It would be a very simple way to do that. You would want to make sure you have your 10 different rows and your 10 different columns, and you could write out your numbers 1 through 100. I used to do this with my students, and on a paper towel roll, I would have them roll up it like a scroll, and that scroll became their hundreds chart that they could go back to and refer to, and we would always take out our hundreds charts when we were doing this particular routine. All right, so what we're going to do today is this is called close, far, or in between. And so I have 3 numbers here. And let's see, I can probably still use this paper. This might work here. So I have the numbers 36, 15, and 23, okay? The very first thing I want us to do is I want us to order those numbers. I want them from smallest to largest. We're going to have to know a little bit about those numbers in order to be able to order them in the right direction, right? Well, we have 36, 15, and 23. What could tell me which one would be the smallest of those numbers? If you said whatever number's in that tens place would tell me where that might be the smallest number, you were probably correct, because I have a number that has 1 10 in it, I have a number that has 2 10s in it, and I have a number that has 3 10s in it, okay? So when I'm figuring out that, let me start first with our smallest number. Our smallest number is going to be 15 because we have 1 10 and 5 1s, okay? Our next number that we're going to be using is going to be 23 because that number has 2 10s and 3 1s, okay? We know that's slightly bigger because it has more 10s than the first number, okay? Now our next number is going to be 36, okay? We want to identify those numbers on our number chart. And since I want to be able to reuse this number chart, I'm going to go ahead and just put sticky notes over where they are. So I want to locate these numbers where they are on my hundreds chart. All right, so I know one of them had 1 10 and 5 1s. So if I'm looking across, I'm looking at how my numbers are organized. I see I have my top row, which is 1 through 10. I know this is also a teen number. Okay, so I'm listening for that number and how it sounds when I'm also saying it. So if I've gone through 1 through 10, my next number was 11, 12, 13, 14, 15. It sits right there, right smack dab in the middle of that row between 11 and 20. All right, I know my next number. I've got to figure out how far is that number from the number I just placed, 15. We are looking for 23. How could I figure out where that number is going to be? I could count by ones, right? Yeah, let's see if I can do that. So if I'm counting by ones, let's see how far apart my next number is, which is 23. 16, that's 1. 17, 18, 19, 20, that's 5, 6, 7, 8. So my number 23 is 8 away from 15. I have one last number, 36. Could I get to 36 a lot faster than counting by ones? Is there a quicker way that I could do that? Probably. Let's see, if I'm looking, I notice some kind of a pattern that's happening with these numbers here in my 23. That the number right above it looks like it has exactly 1 10 less than my number here, and the number just below has 1 10 more. The ones place is not changing. What if I counted by tens to try and get to the next number, or at least one of the tens to try and get to the next number? So if I counted 1 10 by 10, 23, and added 10 more, I would be at 33. So I know I have 10 here, 11, 12, 13. So could I figure out how close or far or in between the numbers are from each other just by looking at the patterns that they're creating from there? Yes, I could. All right, I want to know, now that we've got those 2 numbers, or those 3 numbers that are on the board, which of those numbers is closest to our number 20? Which of those numbers do you think is closest to 20? Maybe you thought 15 was going to be closer because it's in the same row. I thought that at first. I thought, wow, it's in the same row. It's got to be closest, right? No. Actually, the number that is closest to 20 is going to be 23 because it is only 3 away from our 20. Oh, what about the number that's closest to 50? What do you think? You're right. It's going to be 36. 36 is actually closer to 50 than all of our numbers because we have to go a lot farther to get to 50 if we were in our teen numbers in 15 and in our 20s than we would starting from 36. Remember, we can count by 10 and drop down. Well, no, that's 10, 11, 12, 13, 14. It's only 14 away from 50. All right. Now, I have one more kind of strategic question for you. Can you think of a number that's between 15 and 23? Which number do you think you could come up with? Well, I wonder, is that number, how far away is that number between 15 and 23? Could you think of a number that was equidistant between the number 15 and 23? And how could we figure that out? Well, first we probably want to figure out the difference between 23 and 15. So if we know there's how many spaces? 1, 2, 3, 4, 5. Oh, sorry. Let me get right over here because I think I'm in the way, guys. So if we had 15, when we wanted to get to 23, we would go 1, 2, 3, 4, 5, 6, 7, 8. We talked about a number being in between or equidistant from that number. So if we know that there's 8 spaces in between 15 and 23, could we figure out a number that is exactly in the middle of that? You're right, we could. We could say that what is half of 8? Well, half of 8 is 4, because that's the distance in between those two numbers. So if we counted 4 more, 16, 17, 18, 19, 19 would be exactly in between 15 and 23, because there's exactly 4 ahead of 15 and 4 behind 23. Wow, that was some good thinking in using our number line today. Amazing. You guys did an amazing job. That is called close, far, or in between. And it is a great little routine. You can pick any 3 numbers that you want, and you can start saying, well, how far are they apart? What could be a number in between? How much more do I have to go to a particular number, like 50 or 100? And it is very simple to just move around and kind of understand what's happening on your number charts. Great way to explore those numbers. All right, I have another problem for you today that I'm also going to be working with you on. And this is, again, another way to start thinking about how we look at solving problems without having any numbers at all. Have you ever thought about doing a problem that didn't have any numbers? Well, we really want to think about those numbers in terms of the relationships and what they're asking us to do. All right, so this is called a numberless word problem. I'm going to bring this up here. And so what I'm going to do is I'm going to just read some statements to you. And after I read the statement to you, I just want you to think about what those questions are asking you, okay? Or what those statements are saying, and I'm going to ask you a few questions about that, okay? So in order to do this, we kind of don't have any numbers. I think you noticed that. That's one of the very first things that you might say. Well, Mrs. Sears, there's no numbers on there. That's why they call this a numberless word problem, because we're thinking about those relationships and what the numbers are doing, okay? We want to kind of figure out what is the operation that we're thinking about. How do we know it's that operation? What words told us which operations to use? Which words told us the relationships of those numbers? All right, so let's read our first statement. This one is called, or this statement says, there were some friends reading books. There were more friends reading books than playing board games. What are you picturing in your mind right now? I know I'm thinking about, well, there's friends that are playing board games, and there's friends that are playing or reading books. And it sounds like right now that there's more friends reading books than could be playing board games. Did you think of a number in your head of the friends that were reading books? Did you think of a number of the friends who were playing board games? And are those numbers making sense in your head as to there are definitely more students or more friends that are reading those books than are reading or than are playing the board games? All right. So in your head, are you picturing this scenario? You have friends reading books. You have friends playing board games. And right now, there's more friends that are doing that, playing the board games. In my mind, I'm thinking like 3 friends maybe reading books and maybe 2 friends, that are playing board games. Because that would make sense. There's more friends reading books, right? There's 3 versus 2. All right, let's see if we can add some numbers in here. So the second statement, I'm going to read this, and I'm going to ask you some more questions. There were 10 friends reading books. Do we now know how many friends were reading books? Yeah, there were 10 friends reading books. There were more friends reading books than playing board games. What changed? Well, we have new information. We know how many friends, right? We know there are 10 friends reading books. So if there are 10 friends that are reading books, how many friends are going to be playing board games? Is it going to be more? Or is it going to be less? Well, we know there's going to be less friends that are playing board games because we know right now 10 of those friends are going to be more than what's playing the board games. So my 2 numbers that I gave you before, when I thought about 3 and 2, now I've got to think about a different relationship. I know my numbers are, I have 10 friends reading books, but I've got to think of a smaller number of friends that might be playing board games. I don't know what number I would think about with that. Maybe I'd say 5 friends. I mean, at least at this point, I know 10 friends are reading books, and that's more than 5 that would be playing board games. So I'm still not sure exactly what I'm going to have to do with this particular problem, but kind of know the relationship that the numbers have. I have one number that's going to be bigger than the other number. All right, let's get some more information. I'll put this one here. All right, and my sticky fell off with it. So we already know there were 10 friends reading books. There were blank more friends than playing board games. There were 3 more friends reading books than playing board games. New information this time. What changed? Now we know how many more of the friends were reading books than were playing board games. Does this change the way that we could think about this number? Yeah, we know that 10 friends are reading books, and 3 friends are, 3 more friends that are reading books more than that are playing board games. It's a little bit tricky. Could we figure out what this relationship or what this question is going to get ready to ask us? Definitely, probably can. This new information does help us a lot, right? So let's see, could we solve this problem? There were 10 friends reading books. There were 3 more friends reading books, I forgot the S on that, than playing board games. How many friends were playing board games? So it didn't ask me to figure out how many friends more were doing something about the board games. It's asking me actually how many friends are playing board games. Can I figure that out with the information that I have? Absolutely, I can. What are important details that we need to know about this particular problem in order to solve this? Well, we know there's 10 friends that are reading. We know 3 more of those friends are reading these books. I'm going to put that S there, then playing the board games. I need to figure out how am I going to find out who is playing board games. If you said, let's look at the numbers, we can. So what are we going to do? We're going to set this up as a subtraction problem because we have 10 friends that are reading books. We know 3 more of those friends are reading books than playing the board game. So what we're really trying to figure out is what might be this number over here, right? So if we know that 3 more of them are going to be playing, reading books than playing the board games, we know that we're looking for this number right over here. Could also be set up a little bit differently, but I'm thinking, what could I do to figure that out? I could say 10 minus 3, because I know 3 of those friends, at least more, are reading board games. That would be my answer, right? 10 minus 3 equals 7. So now I kind of know how many friends I have there that are reading and how many friends that are playing board games. Pretty interesting how those number relationships work with that problem. Let's have Ms. Gaudette come up here, and she's going to do another problem with us, and we're going to listen to how she's doing that.
All right, you guys. So I'm going to move a few things around. We have a problem from a site that I love. The site is called Inside Mathematics. And what this site does is it just gives you all different kinds of problems that you could work on. So I'm going to, and this one problem takes this far. So all right. So this problem is called Friends You Can Count On. And we're going to read the whole problem through and then work step by step. That's what we're doing together, is just how would I problem solve through this problem. So let's look about it. The friends in your class like to exchange stickers. You decide to give each classmate 3 stickers. You have 19 classmates. How many stickers will you need? Show how you figured it out. Then the next one says, your best friend decides to give each classmate 4 stickers. How many will your best friend need to give away? And then it continues. 2 more classmates join your class. You and your best friend give them stickers also, because it's only fair, right? How many total stickers were exchanged? Explain how you figured it out. Your younger brother wants to give some stickers to his classmates. Explain to him how to figure out how many he needs to bring to the class. So let me get some markers. And the first thing I always do when I'm working a problem is I go through and I underline the questions and I circle the quantities that I know I'm going to be working with. So we first have the quantities. So the friends in your class like to exchange stickers. You decide to give each classmate 3 stickers. So that's the first information we're given. Well, let me circle it with a different color, because that one you can't even see. You have 19 classmates, right? So that's our next number. So our first question that we're being asked is, how many stickers will you need? And then, so I'm going to underline that, because I know I got to underline how many stickers. That's my question. And then it says, show how you figured it out. So let's get up a sheet of paper that we can work on. And let's figure out how could we set this up so that this would be something that's not so hard. All right, I know I have 19 classmates, and I want to give them each 3 stickers. So there's probably multiple ways I could do this. If some of you may do it on the higher end and think about, oh, maybe some multiplication. Some of us will think, no, yeah, I just take 19 and add it 3 times. Perfect. That's the way I'm going to do it. So I'm going to take 19, and I know I want to give each of my classmates 3 stickers. So that would be 1 sticker per person. Now we have 2 stickers per person, and then we have 3 stickers per person. So I'm going to take that, and I look at it, and I said, well, 19 plus 19 plus 19, 27. And then I have 1, 2, 3, 4, 5, 57. So I know I have to give out a total of 57 stickers. Miss Sears?
I'm just thinking that 19,
Miss Sears has another way to look at it.
I don't know, I'm just thinking that 19 is very close to a 20. So if I did 20, 20, and 20, and I said 20, 40, 60, I knew I had to take away, because I just increased that 19 to a 21. All I'd have to take away is 3 of those numbers. So let me see if that stays on its place. So 60 minus 3 would again give me that same 57. Using that number was a little bit quicker for me to figure it out.
Ah, look at that. We're bringing in a number talk for you. Woohoo! So that's a good way to look at it. Is remember, I'm approaching it one way. Mrs. Sears approaches it a different way, and that's okay. Remember, that's the best way to look at it, is that any way you approach it, there's different ways to solve this. All right, our next question. It said for me to show how you figured it out. Did I do that? Yeah, I did that. Now let's move to the next question. Your best friend decides to give each classmate 4 stickers. What do I need to do there? Right, I need a circle. You notice I got another color. I like my multiple colors. So I had to circle. Now I have 4 stickers. And they're giving it to each classmate. How many classmates do I have? 19, right? It's still 19. There's nothing changed there. So my new question that I have to answer is, how many will your best friend need to give away? So how many? So that is my question. Let's move it on. I know I have 19 classmates. If I give them each 1 sticker, it's 19. Then I continue, that's 2 stickers for each classmate. Then I have 3 stickers for each classmate. Now I have 4 stickers for each classmate. So what I'd like you to do before I see you on next Tuesday is I'd like you guys to try to go ahead and figure that out. How many would you give to your best friend would give to your classmates? And the next part you have to do is maybe just think about, we'll work on that next time. So that's what I'd like you to do, is figure out how much for your classmate and think about, could you explain that answer? So we are headed towards the end of our time with you today. And I wanted to thank you so much for joining us with mathematics.
And thank you for joining us with At Home at APS. We'll see you again. Take care.
Bye, everyone.
Bye.